The time has come to talk about the implications of applying async and await in your applications. We're going to discover some of the code that is generated when you apply these keywords. And we'll talk about some of the problems that you may run into because of that. Understanding how async and await works internally definitely makes it a lot easier for you to find potential problems. I've mentioned a few times that introducing the async keyword generates a bit of code, and it introduces something known as a state machine. Understanding the implementation of the state machine isn't as important as understanding its purpose. The state machine is there to keep track of the tasks in your current asynchronous context. It will handle the execution of the continuation and a way to provide the potential result. It also ensures that the continuation executes on the correct context, which means that it also handles the context switching. Of course, in the cases of there being an exception, it's also in charge of reporting the errors from that asynchronous operation which you are awaiting. Let's look at some code to understand this better. Take this search click event handler as an example. This is a very simple method. It hasn't yet introduced the async and await keywords. Let's compile the application and open it in a tool such as ILSpy. This is an open source project that allows you to decompile a .NET application. This provides a way to look at the IL that was generated by the compiler. The generated IL can be inspected as C# code. This is equivalent to what we see in Visual Studio. In fact, it looks identical. What do you think happens if we go back to Visual Studio and mark search click as async without using the await keyword anywhere in the method and then recompile the application? We can see that we're getting a hint that we should probably not mark this method as async unless there's an await keyword in the method. While this is correct, let's leave it like this for now. Let's open the recompiled application and see if anything changed. Behind the scenes, what's going to happen here is rather interesting. Adding the async keyword actually had quite a big impact on the code that's generated. The click event handler now turned into something completely different. This code here doesn't look anything like what we have in Visual Studio. It introduced something called a state machine. A state machine is generated for every method that you mark as async. Each method that you have marked as async will turn into something looking like this. This generated code uses something called the async void method builder, which is something that it's using for methods that are marked as async void. Then it's starting this process using the state machine. The state machine also takes care of things like running the continuation. How about we have a look at the state machine? And here we have it. This is the state machine that was generated for the search click method. The state machine has a reference to the main window class. There's a method called moveNext. In fact, inside moveNext is where everything interesting is going to happen. All the code that we've seen so far is in fact executing on the caller thread. This means that the entire state machine executes on the same thread as search click is being executed on. Can you spot something familiar here? You can see that we have notes.txt. So it took all the code from the search click method and moved it into this generated method. It also put all of the code inside a try and catch block. This shows you why methods marked as async task captures exceptions. If there's an exception, it's going to use what's called the builder to set the exception. It also uses the builder to set the result to indicate that it completed successfully. I'd say that this is a rather drastic change to the code of the application, all with just a simple async keyword. Another important aspect is that when it's using the async void method builder and trying to set the exception, there's no task to set it on, which is why this would tear down the entire application. How about we add a little bit more interesting code to the application? I'm going to create a very simple method called run, which is an asynchronous method marked with the async keyword and returns a task. We'll introduce a simple task that returns a string. The result of this operation will be stored in a local variable. As we await the result of the asynchronous operation, this operation, in this case, immediately returns the string pluralsight. We can compile it and inspect the code in ILSpy. And the first thing that's interesting is that we now have two state machines. We have one for the run method, as well as one for the search click event handler. Let's inspect the run method. The signature indicates that it returns a task, just as we previously stated in our code. What this method actually returns is the state machine's builder's task. This is a reference to all the ongoing asynchronous operations that's currently going on. This task is what will have the potential exception, result, or a cancellation set on it. Again, this here changed the method quite drastically. In this case, we also used the await keyword. If we check inside move next, inside the state machine generated for the run method, it's going to look a little bit different. The state machine keeps track of the current state and has an awaiter to keep track of the current ongoing operation to know if it's completed. While you don't have to understand the implementation in detail, this really just shows the complexity of introducing async and await. To further understand the complexity, let's add some code to the continuation of the run method. Where do you think this code will live inside the generated state machine? At the bottom of move next, that was generated for this asynchronous method, we can see the code that executes the continuation. Again, this shows you that what's generated here is rather complex. It's doing a lot of heavy lifting for us, all to make it easier for us to introduce asynchronous principles in our applications. By applying the async and await keywords, it makes it a lot easier for us to work with these asynchronous principles. The heavy lifting is done by the compiler, and really, it shouldn't be taken lightly. There are a lot of really clever things going on here.